Precalculus first 9 weeks assessment 2, 2019. This test we're having this week, this serves as the review of that test, which I hope the students will be able to adjust and improve. 21 problems total. Which of the following functions is bounded above and below? Well, you can try all of these functions. I'm going to go to my TI-84 CE graphing calculator and put choice B here, which is sine x. So we go to sine x, and we see when we graph a function that is bounded above and below. So for this one, our correct answer is B. Next, for the following function, find the approximate interval over which it is decreasing. We could probably do some analysis without graphing in the calculator, but those techniques are going to be more helpful for in calculus as opposed to pre-calculus. Let's go ahead and enter this function in our calculator. Clear. We're going to put 1/10, so I'm going to make that 0.1. X third power is going to be minus 6x squared minus 15x plus 18 close parentheses graph. I don't know if we have a standing unit. So we can see where we're approximately where decreasing from here to here. We can get it exactly. If we get a window, I'm going to go for the friendly window of negative 3.3. It's going to be our minimum. Our x maximum is going to be, I think, 6.6. You're going to see, I hope, why I did this. So let's look at that window again. Yeah, trace step 0.075. That should say something. So we're going to trace, and so we go over to the left, right at this maximum. So right here, x equals negative 1.5, and now we're decreasing. So we've already gone from x negative 1. We already have our answer to x equals approximately 5. So there it is. Our correct answer is C. Next, 3. Which following functions has a vertical asymptote? Well, I'm not even going to graph this in the calculator. Your square root of x function is like this. Your sine x function is like, we already saw that. Sine x is like this. No vertical asymptote. X squared is like this. No vertical asymptote. But if we graph this 1 over x plus 2, x plus 2 cannot equal 0. So x, subtract 2 from both sides, x cannot equal negative 2. So we have vertical asymptote, x equals negative 2. So the function looks something like this. Yes, only one possible. 4. Each of the following functions has a discontinuity. Which one has a removable discontinuity? I'm going to show this graphically, but before I do that, I'm going to resort to finding the factors of this rational function. So here, in the numerator, if we factor out this x squared plus x minus 30, well, we're going to get x, and what two numbers do you multiply together, one positive and one negative, yet add together to get 1? Well, we're going to have x plus 6, that's going to be x minus 5. That's going to be over x minus 5. And then it's going to be the same thing in the numerator for all of these. We're going to get x plus 6, that's going to be x minus 5 over x plus 5. This one here, choice C, we're going to get x plus 6, there's going to be x minus 5, all over x minus 6. And then the last one we're going to get x plus 6, x minus 5, over x minus 30. Each one of these functions will produce a vertical asymptote except for answer choice A, because x minus 5 cancel each other, and this would be evidence of a removable discontinuity. And to graph this function, we go to our calculator and clear that. Go to alpha, y equals, enter. I'm going to put in x squared plus x. Oops. Plus x, or minus 30. Down here we're going to put x minus 5. I'm going to get a standard window zoom 6. We see nothing, no breaks at all. This is not a vertical asymptote, therefore not a non-removable discontinuity, but a removable discontinuity. All these other answer choices, B, C, and D, will produce vertical asymptotes. A is our correct answer. 5. Which of the following functions has as a vertical asymptote the line x equals 5? I don't know how factorable A is, probably not. But here, for choice B, we can set our denominator not equal to 0. So if we add 5, x cannot equal 5. For answer choice C, x cannot equal negative 5. Yes, our vertical asymptote is going to be x equals 5, and there's really no excuse with the calculator in hand why you would not get this right. Why would you not take the time to verify 1 over x minus 5? Yeah, x minus 5. Pretty clear. That's your vertical asymptote. X equals 5. Next, 6. Compare the function of y equals 3x minus 6, which is its inverse function. Well, in this class we've had like we put a f of x and we changed into f negative 1 of x, the inverse function notation, but we see no such thing here. So what we're going to do is take this y equals 3x minus 6 and switch places with x and y. So we're going to rewrite this as x equals 3y minus 6, and I'm just going to turn this around to get the y's on the left side, so we can rewrite 3y minus 6 equals x. Add 6 to both sides of the equation. We get 3y equals x plus 6. Divide both sides, all terms, by 3. We get y equals 1/3 x plus 2. No question about it. Next problem, 7. What is the domain implementation of the function shown below? In a radical, under a radical square root, we know that 7 minus x has to be what? Greater than or equal to 0. And we can solve for x a number of ways. One way I'm going to do it here is just add x to both sides. So we get 7 is greater than or equal to x. And turning that around, x is going to be less than or equal to 7. In interval notation, this 7 becomes bracketized the right side, and we're coming from greater than negative infinity, so it's going to look like this right here. And where do we see that? Answer choice A. Very easy to graph this function as well. Go to the calculator, square root of quantity 7 minus x. So graph this. You can see it. Okay, negative infinity. And the only thing you can check, does the thing actually exist at 7? Because that makes a difference per second graph. We can see that the function is defined for x equals 7, but not anything over 7. So that makes A definitely our correct answer. 8. What is the domain and interval notation of the function shown below? Again, our function is undefined where our denominator is equal to 0. So we can set our denominator, in this case x squared minus 2x, not equal to 0. And solving this equation, we have a common factor of x. So x times x minus 2 cannot equal 0. And so we can take each of these factors using the zero factor property of algebra. X cannot equal 0. And also x minus 2 cannot equal 0. So therefore x cannot equal 2. So our critical numbers we're looking for are 0 and 2. Well, this kind of looks, we don't have 0 and 2 here. We have negative 2 and 0 here. Here we have no breaks. This is where we have 0 and 2 as our values of discontinuity. Now, which the following has a range of negative 1, comma 1? It's going to be very similar to the first one we graphed, but it's going to be, in this case, cosine of x. So if we press cosine x, so we just trace. Okay, we have a maximum of 1. Here, minimum of -1, about, so yeah, it's going to be answer choice B. Next, 10, a function is represented with three sets of word pairs, 1, 2, 2, 4, and 4, 9, which the following sets of word pairs represent the inverse of that relation. This relation, you take these here, and all we do is x's become y's and y becomes x's. So instead of 1, 2, we're going to have 2, 1. Instead of 2, 4, we're going to have 4, 2. And the last one, instead of 4, 9, we're going to have 9, 4. Where do we see this in place? Looks like D, doesn't it? Next, 11. Which following rational functions has no discontinuities? Well, here for A, we know that the x squared minus 4 cannot equal 0. So using the difference of squares, we can rewrite this as x plus 2 cannot equal 0. X minus 2 cannot equal 0. So there are definitely two discontinuities there. This one here, if we set, say, x squared plus 1 cannot equal 0. And we solve by subtracting 1, x squared cannot equal 1. Can we solve by square root method? No. There's no real number that we cannot do anything that will make this work. So this thing here is never going to possibly be 0, because x squared can never be less than 0, and we have to have this thing here equal to -1 for that to happen. So that is where we have our, that's negative x squared cannot equal -1. So we have x equal to plus or minus square root of -1. That's an irrational number. Next, 12. If fx equals 2x minus 3 gx x plus 1, find f of g of x. Well, we have closest to the x's and g, so we'll take this g and plug it in for the x here. And for that, we're going to have f of g of x is going to be equal to 2. I'm going to leave this gap here, minus 3. And into this gap here, we're going to put x plus 1. So for this, we're going to get 2x plus 2 minus 3, which equals 2x minus 1, which is our answer choice A. Next, 13, which function is the inverse of the function fx equals x cubed plus 1? Well, the four-step process. Step number 1, we're going to let f of x be changed to y, so we get y equals x cubed plus 1. Next thing we're going to do is switch x and y. So instead we rewrite this as x equals y cubed plus 1. And then I'm going to switch sides, y cubed plus 1 equals x. Subtract 1 from both sides of this equation. So you get y cubed equals minus 7, wasn't it? Minus 1, okay. X minus 1. Take the cube root of both sides of this equation. So y is equal to cube root of x minus 1 So that's going to change this to g of x. That's going to be answer choice A. Next. 14. What is a horizontal asymptote of the function f of x equals 3x cubed minus 2x plus 3? Well, there are different strategies we can use. One thing we can do is we can put in a very large number and see which number is closest to these answer choices. So if I say x equals a real large number, we can make it 1,000,000. How do we do that? Yeah, let's put a calculator. Get out of this view here. I'm going to put 1,000,000 in storage, the STO key, x. Let's enter. We've stored 1,000,000 for x. So now we can just go to our expression and enter 3x cubed minus 2x plus 3. And in the denominator, we have 4x squared minus x cubed. Okay, so we enter that, we get negative 3.000012. What is that close to? Yeah, negative 3. Another thing we can do is we can use what we call Betsy, take the terms with the highest coefficient value, or highest exponent. We got 3x to the third power divided by negative x to the third power. So the value of our horizontal asymptotes will be 3x cubed over negative x cubed. And what does it simplify to? Negative 3 over 1 equals negative 3. What is the inverse of the function f of x equals 2x plus 3 over x minus 1? And we can just do our process like we've done in the past. X equals, let me put y, I'm going to do it one step at a time. Y equals 2x plus 3 over x minus 1. And we switch x and y's. We rewrite this as x equals 2y plus 3 over y minus 1. Okay, if we cross multiply by y minus 1, on the left side we get x times y minus 1, and on the right side we get 2y plus 3. And we distribute on the left side, we get xy minus x, and on the right side we still get 2y plus 3. What we're going to do is everything with a y in it, we're going to bring to the left side. So I'm going to subtract 2y from both sides of this equation. And let me see, I just got this wrong here. It's supposed to be 2y minus x. That's a big deal. So we get xy minus 2y minus x is equal to 3. Now if we add x to both sides of this equation, we get, I'll bring this up here, we have xy minus 2y. And on the right side, we have left x plus 3. And now if we factor out a y times quantity x minus 2 is equal to x plus 3. And then dividing by x minus 2, we get y equals x plus 3 over x minus 2. So f negative 1 of x equals x plus 3 x minus 2. Where we see that? Answer choice B. I'll call that provisionally the case. What I want to do for that is show you on the calculator by graphing how we can demonstrate that that's the case. Put it out, enter. We're going to put original equation here, 2x plus 3 over x minus 1. So we get this. And then we're going to put a line y equals x. So we're going to see this graph reflected if we're correct about this x. So this thing's going to come right over here. So it's going to kind of shift. We will see its symmetry, I hope. So now we go to our supposedly correct answer, which is x plus 3 over x minus 2. And we'll graph that. And I don't know if you can see this. I'm going to go to zoom square to get a more proportionally correct look at it. So these are reflections about the line y equals x. Okay. Next. 16. Which following parent functions has as its end behavior f of x as x approaches infinity equals 0? Well, we covered this a couple weeks ago when we examined the parent functions of precalculus. Be more or less straight line, come on. Okay, so this answer choice A will go like this. So we're going to be approaching 0 as x approaches infinity here. So that is our correct answer. 17. Which following functions exhibits odd symmetry? And so for odd symmetry, what are we looking for? We're looking for 180-degree rotational symmetry. And so these ones here, like answer choice B is the square root function, looks like this. Answer choice C is the quadratic function, neither of these with rotational symmetry. This one here, cosine x, goes something like this. Not rotational symmetry, this is an even symmetry situation. No, it's this cube root of x. I'm going to go with that in. Rotational symmetry. And I'm going to just see if we can do this. Oops, I got the wrong one. I want to get this one here. See, rotational symmetry. I didn't get it exactly right, but There it is. Answer choice A. (18). For the graph of the function pictured below, what are the approximate coordinates of one of the local maxima? Well, our choice for maxima will be right here and here. So it either be, that's -1, 2, 3, 4, 5, 3. So you have -5, comma 3. Or over here, we're going to have 1, 2, 3, 4, 5, 6, about 7, comma 2. So that's going to be answer choice B. Next, 19. If f of x equals x plus 1 over x and g of x equals x, what is f of g of 2? What we're going to do is, first of all, find g of 2. So g of 2, and we're going to replace x with 2. So g of 2 equals 2. And what do we do with this 2? We plug it in for that x here, and also branch off here for this x. So f of g of 2 is going to be equal to 2 plus 1 over 2, which is going to be 5/2. And we need to put a decimalized answer here, so that's going to be 2.5. So 2.5 goes in here, 2.5. And the gridding assumes positive unless otherwise notified, so we don't have to fill in the positive here on the left. So we put in 2.5. Next, 20. Elevation phi of Plymouth football is given by the function of t5 plus 24t minus 60t squared, where t is the number of seconds. So nearest tenth second, how long after being kicked is the football reached maximum height? So what you're going to have is how long. So what this is when what. So when, in this case, how long is going to be the x-coordinate of our maximum. So let's put this in the calculator. 5. One. There it is. Let me clear out these guys here. Clear. We're going to put in 5 plus 74 x minus 16 x squared, and we graph that, and we see we have a certain geometry there. I'm going to change the window. X minimum, I'm going to go to 0. X maximum, I'm going to call 6. Y minimum, we can start at 0. And Y maximum, I don't know exactly how high it goes. I'll put 100 feet here. Graph. So we're going to be okay. We can trace to the top. One thing I'm going to do is go to second trace where it says maximum, which is 4. It has the question left bound, so I need to scroll my cursor over here to the left side of that maximum. So as soon as we get over to the left side of that maximum, which is where we are now, press enter, and it says right bound. We go to the right, press enter, and then enter one last time, and we get our maximum of 99.56 where x equals 2.31. So we're going to put 2.31, comma, 90.56. And it says to the nearest tenth. So we would call this 2.3, comma, 90.6 in tenths. Which one is our correct answer? Okay, when? It's this thing, the time. Okay, the 90.6. Have you ever kicked a ball and it's been 90.6 seconds in the air? No, no. Try to look at these problems. Are the attempt to make these more or less real world realistic. So just look for that. If it's not somewhat imaginable, just double check yourself. Common mistake. A lot of people will go ahead and pick this second value for height. And a problem like this, it's usually time or position. 21, the last problem we have, the rational function g of x equals x over x, 1 plus x squared contains how many discontinuities? We can set our denominator, as always, equal to 0, or not equal to 0. So x cannot equal 0. That's one discontinuity. And also, using zero factor property, 1 plus x squared cannot equal 0. And if we subtract 1, x squared cannot equal negative 1. And if we take the square root of x squared, equal plus or minus square root of negative 1. So x cannot equal plus or minus square root of negative 1. Is this square root of negative 1 a real number? No, it is not. So we do not have a discontinuity here based on 1 plus x squared, but we have one based on this particular x here. And so we have one discontinuity in this rational function. So that's it. I hope this helped to you. Good luck, and thanks for viewing.